Hello everybody, today we're going to start on day 3 notes, maybe, if I can get the big screen going. There we go. We're going to start on day 3 notes of Unit 7. Today we're going to talk about the special cases that happen with polynomials, and we're going to go ahead and start talking about factoring. Factoring, not in case you don't know, because you don't know, factoring is basically trying to figure out, like, if you get a trinomial or some kind of polynomial, you kind of work backwards and undo the distributive property to find out what things got multiplied together to create that product. Okay, so factoring in general is undoing distributive property. Okay, I'll show you different ways you can do it, and yeah, let's go ahead and get started. Sorry, I'm getting a little sick, so I apologize right now if I sniffle in front of you. It's not the funnest thing to hear, but hey, we're going through it. Okay, so there are two kinds of special cases when we deal with polynomials. One is the square root binomial, which literally is a binomial squared. Now let's talk about this a little bit, because what this means is actually that you're multiplying the same binomial together. So you would write it out and actually want to... Oh, I guess I could have just typed it. So what this means, instead of like... Oh, goodness, I can't talk today. I apologize. When you have a binomial squared, what it means is you're doing that binomial a plus b times itself, a plus b. Okay? It does not mean anything about distributing that exponent. Okay? We can't distribute the exponent because these a and b are not being multiplied. We can only distribute over multiplication or division, not over addition. So what it means is that you just take the binomial and write it twice and then multiply like normal. Okay? And then the other one is the product of the sum and the difference of binomials. So same binomial, but just one's being added, one's being subtracted. These are the special cases. And they actually do make a difference, because if you get this, you need to know that it means you're multiplying the same thing. This one, you kind of really don't need to know about. If you know about this one, it kind of helps you take a shortcut to factoring or multiplying. And I'll tell you about those shortcuts. This one also has a shortcut, but the biggest thing, you need to be able to recognize that. Because if you don't understand that it's the same binomial being multiplied, you're not going to be able to multiply it correctly. So let's go ahead and get started on what these actually mean for you. So a square root binomial, when you multiply it out, remember we're saying that we're really doing, just give me a second to type it, a plus b times a plus b. And a and b, like, one will be a variable, one will be a number kind of thing. So that's what you're really doing. So when you multiply these together, what it comes out to be is whatever a was, it's going to be squared. The middle term will be 2 times a times b, whatever a and b are. And the last term will be whatever b is squared. So that's your shortcut. If you're able to recognize, oh, this is happening, all you need to know is what the first term is and the second term, and kind of fill this in. You don't actually have to do the box method. You don't have to do the distributive property. You don't have to do FOIL for it. You can. The shortcut is just that, like, like, you have blanks to fill in, so it's a little bit easier. You don't have to worry about doing all that multiplication. But if you want to do the multiplication, that's totally fine too. It still works the same way with all those different methods. Okay, so here's an example. We got the square root binomial x plus 3 squared. Okay, so what that means is that we are doing x plus 3 times x plus 3. You need to expand it out. Whenever you have exponents on like a polynomial, write it in expanded form. Okay, so in this situation, the x in the front is the a term from that general one from the last slide, and the 3 in the back is your b term. So you can fill that in, the a squared plus 2ab plus b squared, really easily just using this. So first you're going to square whatever a was, which was x. Then you're going to do 2 times a and b, so x and b, or sorry, x and 3. And then you're going to do the b squared, so 3 squared in the back. And just simplify that. So you get x squared plus 6x plus 9. That's your answer. So that's a shortcut way. However, it's kind of like, that's a lot to memorize. I personally don't memorize it because there's a lot of other things going on I'd rather use my brain power for. You could still use FOIL or box method or anything. So I'm going to do it with FOIL. Now that I have 2 binomials, I could do x times x gives me x squared. The outer ones, x and 3, do that, I get 3x. Inner is 3 and x, do that, I get 3x. The last are the 3 and the 3, and that gives me 9. So I take them, I write it out, so it's actually a polynomial, and I combine like terms. I get the same thing. So the biggest takeaway from square a binomial is that that binomial is being multiplied by itself. You have to write 2 binomials for it. Okay, so not too bad. The product of the sum and difference of a binomial. So, like we said, it's a binomial times itself. The only difference is one's adding and one's subtracting. This is a real shortcut, which is really nice because it's not that much memorization. When you multiply these together, you get whatever a is squared minus whatever b is squared. So, take, whatever a is in the front, square that, whatever b is in the back, square that, and put a minus sign in between. That's all you got to do. It's really nice. So here we have to do x plus 5 times x minus 5. So x in the front is your a, and the 5 in the back is the b. So you're just dealing with the numbers for b, not the sign, okay? Whatever number they have in common is your b. So to do the shortcut way, square a, which means you're squaring x, and then square the 5, which is your b, and simplify that, x squared minus 25. That's your answer. Again, you could also do it with FOIL, and I'll show you what happens when you do it with FOIL, which is why the shortcut is preferred. Because when you can't see the problem now. When you multiply x times x, you're going to get x squared for your first. The outer is your x times negative 5, so you get negative 5x. The inner is 5 times x, giving you 5x. And the last would be 5 times negative 5, giving you negative 25. So when you put it together to create a polynomial, your middle terms actually will always cancel out. That's why you just need to do the a squared plus b squared. Okay? And you get x squared minus 25. So this stuff will help you when we get to factoring, because if you know the shortcuts on how to multiply, you'll also know the shortcuts on how to factor, getting it back to those 2 binomials, which is really nice. All right, let's talk about factoring a little bit. So today we're going to talk about factoring out of GCF. GCF is your greatest common factor. That's what it stands for. And we're talking about it between 2 terms, or multiple terms for that matter. So find the GCF between 28 and 42. We're just going to practice finding the GCF, not actually factoring anything yet. So when you're trying to figure out the greatest common factor, what you have to do is you have to figure out what are all the things that got used to create that number. So factors of 28 would be 1 and 28, 2 and 14, 4 and 7. Those numbers are all the numbers you can multiply together to create 28. Same thing with 42. You got 1 and 42, 2 and 21, 3 and 14, 6 and 7. If you multiply those together, you'll get 42. Those are the only numbers that work. Now, that you know the factors of these 2 numbers, you can figure out the greatest common one. So what's the biggest number they have in common? 14. So the GCF between these 2 numbers is 14. So now we're going to apply this with our polynomials. So we're going to factor out what they have in common. Okay, so when we're dealing with polynomials, you not only are just looking at the numbers, like what do they all have in common, basically like what can you simplify all of them by. You also need to look at the variables they have in common. Okay? So let's talk about this. So we're just basically trying to undo distributed property. What can we take out? Like what can we divide all of these by? And then put it in the front. Okay? So we got negative, so let's start with the numbers. -6, +18, and -16. Now if there's a negative in the front, you should try to take out a negative number, just so you can make it just looks prettier. Okay? You want to try to create your polynomial to be a positive if you can. So if I look at -6, +18, and -16, they can all be divided by 2. They can't be divided by 3. These guys can, but this one can't. They can't be divided by 4. 5, 6. 6 is as high as I can go because that's the smallest number. So 2 is the highest number. Now I'm going to take out a -2 just so I can change this to be a positive leading coefficient. It's just because it's like good grammar for math kind of stuff. So I divide everything by -2. So I pull that out to the front, and then it creates these parentheses. Like I'm basically creating the problem for distributed property. So if I divide all of these by -2, divide this by -2, I'm left with a 3 there. Divide this by -2, I'm left with a -9. Divide this by -2, I'm left with a +8. Okay? So it's kind of like simplifying the fraction. But instead of like just doing like dividing by the number on the side and no one sees it, we actually have to put it out front. Okay? This is what people forget the most, is to put whatever they're dividing by in the front. They give me the simplified trinomial, but they forget to tell me what got multiplied with it. So now I need to look at the variables. Okay? So this one has x to the 4th, which means there's 4 x's. This one has x to the 3rd, which means there's 3 x's, and this one has x to the 2nd, which means there are 2 x's. They all have at least 2 x's. So that's what I can take out. 2 x's from each of these, which means I'm taking out x squared. And then I'm going to write what's left over. So if I take 2 x's away from this, I'm left with x squared. If I take 2 x's away from this, I'm left with just 1x. If I take the 2 x's from here, I'm not left with any x. So I just have the 8 on the end. Okay? Now what I just did was I figured out that in order to create this trinomial, I would need to multiply -2x squared times this, 3x squared minus 9x plus 8. That's what I just did. I just found out what got multiplied together to create it. Okay? Which means that my factored form is this. Okay? And I leave it like that, because they're asking you to work backwards when they're asking you to factor. Okay? Please do not multiply this back together, because you're just going to go right back to the problem, which I already know the problem. I don't need it again. Okay? Alright. I wonder if I gave you guys any try on your own. Oh well. So those are the notes. Please let me know if you have any questions, and we will go over it next class for sure. I think next class is like English SOL times. So basically whenever I see you next, we can discuss any questions you guys have. Okay? Alright, bye guys.